Hello everyone. In this video, we are going to see steady state AC analysis based question. And this question will be purely based on phasor analysis. In this question, several data is given to you. Uh, the source voltage is given as 50 root 2 sine omega t plus 30, and the source current magnitude 15.366 ampere. This is the RMS value, and current flowing through this branch is 4 ampere, and voltage across this inductor is 40 volt, and this capacitive reactance is minus J3. We need to find out the angle between Vs and Is. So to I know the voltage angle, but I don't know the angle of the Is. So to calculate the Is phasor, I must know the you can say total current, and at this point, like if I apply KCL at this point, I should be able to know the the phasor of the source current. Okay, so for that, what I'm going to do, I'm going to do the phasor based analysis that is essential for any AC circuit at a steady state. So for all these three branches, voltage is same. Okay, and generally in phasor analysis, we consider that quantity as a reference, which is same for maximum quantity. Okay, so if this is my reference phasor means 0 degree, you can say. My source voltage phasor is somewhere here, Vs, and this angle is 30 degree, right? This is 0 degree, you can say. And if you see the current in this branch, the IL current, this current will lag the Vs by some angle because it is a RL type of load. So current flowing through this branch will lag. So maybe that current will be somewhere here, IL. Vs magnitude I know 50 volt, IL magnitude I know 4 ampere, but I don't know the IL phasor. That is something we should be able to know to comment on the angle between Vs and Is. But in this IL phase, if I draw the voltage, if I say this is my VR2 voltage across R2, so that will lie in this phase VR2, and voltage across this inductor VL, that will lead the, you can say, the current by 90 degree, right? So this is my VL, and this angle will be 90 degree. Okay, so you know the VL magnitude, that is 40 volt. You can comment on the VR2 phasor. So VR2 will be right angle triangle, 50 square minus 40 square, it will be 30 volt, right? So since it is right angle triangle, you can apply this Pythagoras theorem, right? So you can get the VR2 voltage across resistance is 30 volt. And if I talk about the phasor of this VR2 phasor will be 30 at an angle of this angle. Let me call it as alpha. That is something that we don't know. Again, then we can calculate this angle. So if I want to know the calculate, if I want to calculate the angle, let's say this particular angle I'm talking about, mm, this angle, this total angle between Vs and IL. So that angle, I am calling this angle as beta. Okay. And if I write sine beta equals to 40 by 50. So here beta will come around 4 by 5. It is 53.13 degree. So my VR phasor is 53 point, no, with respect to reference we have to see, right? So this angle should be beta minus, you can say 30 degree. Beta minus 30 degree will be, beta is 53 minus 53.13 minus 30 degree. So 23.13 degree. So minus 23.13 degree, because I need to know this alpha, because all the angles are measured with respect to reference phasor. Here if you see the beta angle, it is angle between IL and VS. And this angle is 30 degree. So I need to subtract this angle to get the alpha. So this is the VR to phasor volts. Okay. Now the IL phasor will be, IL phasor should be 4 at an angle of alpha. And alpha is simply here, let me write down, alpha is equals to beta minus 30 degree. And beta 53.13, 53.13 minus 30, it will be minus 23.13 degree ampere. And the capacitor current IC1, so this current will be IC1 current, that should be 50 by 3 at an angle of 50. The source current is 50 at source voltage is 50 at an angle 30, and if you take the capacitive reactance in polar form, that is 3 at an angle of minus 90, so 50 by 3, 120 degrees, so it will be 50 by 3, so 16.67 at an angle of 120 degree ampere. Okay, I know this current in phasor format. If I anyhow know the IR current, that will be easy for us to comment on that. So let me consider this particular current as Ix, and Ix is summation of, so let me write down here, Ix is summation of IC1 phasor plus IL. Okay, this current and this current phasor summation, if you do, you will get that Ix current phasor. So let me do that. 4 at an angle of 4 at an angle of minus 23.13 plus 16.67 at an angle of 120 degree. 13.68, 109.89 ampere. So I know this Ix. Now if I apply KCL at this particular node, so the KCL should be Is phasor is equals to Ix phasor plus IR phasor. Okay. For Is phasor, I know the source current as 15.366 ampere, 15.366. Let me call this angle as theta because we know the angle. And Ix phasor is simply 13.68 at an angle of 109.89 plus IR1 phasor. And this IR1 phasor is simply IR phasor. If it is IR1, okay, so it should be IR1, so IR1, and this phasor IR1 phasor, I can write down IR1 phasor is equals to the IR1 magnitude, and angle should be same as the source voltage, because for resistance angle will always be same, so that angle will be 30 degree. So 30 degree. So if you do this addition, and if you take only modulus, you will end up with 13.68 whole square plus IR1 whole square plus 2 into 13.68 into IR1 cos of 109.89 minus 30 degree, 79.89 degree. I'm only taking the magnitude. Okay, so what you will get, 15.366 whole square minus 13.68 whole square under root 15.366 15.366 whole square minus 13.68 square. So you will get 48.97 uh, is equals to IR1 whole square plus 2 into 13.67 into cos of 79.89. 4.8 IR1. So the IR1 value will come around magnitude 4.8 plus 48.97. It will come around 5 ampere, and the second root is coming minus 9.797. This particular value will simply you can neglect because I have considered the magnitude. Magnitude cannot be negative. So this you can just neglect. The IR1 value will be 5 ampere. So if I just write the IR1 phasor, that will be 5 at an angle of 30 degree, because for resistor voltage and currents are in same phase. Now I know the IX phasor, that is the Ix phasor, this one, and I know the IR1 phasor. Now I can calculate the source current phasor, right? The source current phasor, IR1 phasor plus Ix phasor. So calculate these two quantity, add up these two quantity, 13.68 at an angle of 109.8, 13.68 of 9.89 plus 5 at an angle of 30 degree. So the magnitude you already know, 36 at an angle of 91.208. So the angle phi should be 91.208 minus 30 degree, right? Because my phasor of this voltage source is 30 degree lead. So that should be 91.208 minus 30. It is 61.208 degree. So your current is simply leading. So this is the actual answer of this. What is the phase difference in between Vs and Is? And basically you can calculate like this way. So I hope in this particular problem, like, it is clear to you how to approach the circuit whenever you need to do a steady state AC analysis, the phasor domain analysis basically. If you have any doubt regarding this question, you can ask me in the chat box. Yeah, thank you.